All right, today we're going to dive into a really clever and, yeah, kind of quirky feature from the C programming language, the union. It's this fascinating tool for managing memory, born from a time when, believe me, every single byte was precious.
So let me start by asking you a question, a little puzzle. Imagine you need a variable that can hold an integer or maybe a float. But here's the catch. It's never going to be both at the same time. How would you build that to be as memory efficient as humanly possible? Well, you just stumbled on the exact problem unions were invented to solve. The core idea behind it is just brilliantly simple. Seriously, think of it like a single parking spot. You can park a car in it, you can park a motorcycle in it, or you can park a scooter in it, but you can only have one of them in there at a time, right? That, in a nutshell, is the essence of a union.
So let's get official. What exactly is a union? We're calling it the one-slot toolbox, and you'll see that analogy is a perfect fit for how this thing works. Okay, so here's the textbook definition for you. A union is a user-defined type that lets you store different data types, like an integer, a float, a character, all in the exact same memory location. Now, the phrase to tattoo on your brain here is exact same memory location. That's the key. And this brings us to the golden rule of unions. Because all the members share that one single spot of memory, only one of them can be real at any given time. So if you store an integer and then right after you store a float in that same union, that integer isn't just hiding, it's gone. Poof, completely overwritten, vanished. To really get a feel for the power of a union, we have to compare it to its much more common cousin, the struct. Let's think of this as a tale of two toolboxes, each designed for a totally different kind of job. This slide lays it all out perfectly. A struct, that's your organizer. It sets aside a separate space in memory for every single one of its members. So its total size is basically the sum of all its parts. But a union? Oh, a union is an optimizer. It only carves out enough memory to hold its single largest member, and all the other members just have to take turns using that same space. That right there, that's the memory-saving magic. Now, here's where it gets a little tricky. Despite how completely different they are in how they handle memory, the syntax for writing a union is almost identical to a struct. You even use the same little dot to get to the members. So, they're easy to write, but you have to be so careful you know which one you're actually using. Okay, theory is one thing, but let's actually see this thing in action. We're going to pop the hood and see exactly how a union plays with that single block of memory. Let's walk through this step by step. First, we define our union. Let's call it data, and it can hold either an integer or a float. Okay, step 2, we assign an integer to it, say the number 65. Right now, that memory space holds the bits that represent 65. But then, we turn around and assign a float, like 1.23, to that very same variable. And this is where you see it happen. The bits for that integer are just wiped away, totally replaced by the bits for the float. One space, one value, one at a time. So this is a pretty neat trick, right? But you're probably wondering, where is this thing actually used? Time for a little reality check on its specific but still really powerful applications. But before we get to the cool uses, we gotta cover the rules of the road. Unions are really designed for simple, primitive types. We're talking single values like an int, a char, or a float. You can't just toss in complex stuff like strings or other structs. And that's by design. It's what makes the union a specialized tool with, limited, but really important applications. All right, keeping those rules in mind, where on earth would you actually run into a union in the wild today? Well, you'll find them anywhere and everywhere, that every single byte of memory counts. Think about the super constrained world of embedded systems, the little chip inside your microwave or some tiny sensor. They're also a huge deal in networking, for handling data packets that could represent different kinds of information. And of course, in any kind of low-level programming where you're talking directly to the hardware. Oh, and hey, for all you competitive programmers out there, here's a little pro tip from our source material. While this is a fantastic concept to have in your back pocket, you're probably not going to need a union to solve a typical caddis problem. It's much more of a specialized, real-world systems kind of thing. So let's bring it all home. Let's wrap this up. Why does understanding this classic C feature still matter today? What's the big takeaway?
The key takeaway is really this. A union is a deliberate, conscious choice for memory efficiency. It's your way of saying, hey, I know my data is only going to be one of these things at a time, and I'm going to leverage that fact to save space by making one memory slot do double duty. And that really leaves us with one final thought, doesn't it? I mean, memory is way cheaper and more abundant today, but does that really make efficiency an outdated idea? Understanding tools like the union isn't just about saving a few bytes. It's about fundamentally understanding the machine you're working with and making smart, intentional choices. So I'll ask you, is efficiency ever really a bad idea? Something to chew on. Thanks for tuning in.